Beneath the shadows of Geneva, far below the world's surface, lies a stunning achievement of human innovation and an inevitable harbinger of devastation, the Large Hadron Collider, LHC. It stands as a marvel of intelligent analysis, allowing scientists to probe the subatomic realm and triggering the discovery of the elusive Higgs boson, often dubbed the God particle. This breakthrough has captivated the scientific world, yet, as renowned physicist Brian Cox once ominously declared, a hidden potential has been uncovered at CERN, sparking a 34 seconds wave of curiosity and concern. Could our pursuit of knowledge have led us down a dangerous path? Have we set our course for an uncertain future, possibly one that defies our understanding? Before delving deeper into this startling statement, it's essential to first examine the colossal machine that is the Large Hadron Collider. Operated by CERN, the LHC is an imposing 17-mile ring of superconducting magnets, and it is by far the largest and most powerful particle accelerator ever built. It stands as the pinnacle of scientific accomplishment. 1 minute and 9 seconds. Capable of recreating conditions that rival the birth of the universe itself. This incredible apparatus allows scientists to explore the fundamental components of the cosmos. But with such immense power, could it lead us to unforeseen consequences, possibly even into the realm of the unknown and terrifying? Founded in 1954, CERN has become one of the world's most prestigious and vital research centers, boasting 23 member states and a vast network of experts. While the LHC is its most high-profile project, it is only 1 minute and 42 seconds. Part of an expansive array of accelerators and detectors aimed at understanding the universe's smallest components. The LHC is a race to uncover the very building blocks of existence. It accelerates protons to nearly the speed of light, sending them on a collision course that simulates the energy and conditions of the universe at its inception. The temperatures produced are millions of times hotter than the sun's core, while an intricate web of magnets guides these particles along their journey. At the same time, 2 minutes and 13 seconds. Sophisticated cooling systems maintain the system's supercold environment, far colder than even outer space. The LHC is equipped with 1,232 dipole magnets that steer the proton beams and 392 quadrupole magnets that focus the beams just before they collide. Another crucial type of magnet helps increase the probability of collisions by pushing particles together with incredible force. Essentially, CERN's mission is to collide particles with such precision that it is akin to hitting two needles placed 6 meters apart. 2 minutes and 47 seconds. Accuracy required for this operation is staggering, and the technology involved is unparalleled. The collider's construction features concentric rings placed deep underground, shielding them from the harmful effects of radiation. To achieve optimal performance, the entire system is cooled to -456 degrees Fahrenheit, colder than even the vacuum of space. The underground setup houses 4 distinct particle detectors: Atlas, CMS, ALICE, and LHCb, each with a unique purpose in investigating various aspects of particle physics. These detectors are 3 minutes and 23 seconds. Equipped with massive cameras that capture the particle impacts, with experts constantly analyzing the data in search of traces of the elusive Higgs boson. The Higgs boson is thought to be integral to understanding the very fabric of the universe, offering insights into its essential structure. In many ways, studying the microcosm helps us unravel the macrocosm of the universe, much like solving a massive cryptic jigsaw puzzle. However, with each piece we place, new questions and mysteries emerge, reminding us that every discovery leads 3 minutes and 57 seconds to another challenge. The LHC is not merely a scientific tool, it is an embodiment of human ambition, progress, and the relentless drive to comprehend the fundamental forces that shape our universe. But as we venture into the unknown, we must also confront the moral and existential dilemmas that accompany such daring exploration. What are the potential risks of delving into the unseen? Could our quest for understanding unleash forces beyond our control? In recent months, an unsettling revelation has sent shockwaves through the 4 minutes and 31 seconds scientific community. Brian Cox, a former CERN researcher and prominent voice in the field of particle physics, made a statement that has both intrigued and alarmed his colleagues. According to Cox, the LHC's mission to recreate a miniature version of the Big Bang, reproducing the very event that gave birth to our universe, could lead to unforeseen consequences. The collider's impressive ability to probe the Higgs boson and explore the enigma of dark matter, a substance that constitutes a significant portion of the universe. 5 minutes and 2 seconds. Could potentially unlock truths beyond our comprehension. While the idea of uncovering the universe's deepest mysteries is exhilarating, it is also fraught with risk. The LHC recreates the extreme conditions present at the universe's inception, simulating temperatures, pressures, and energies unlike anything we can observe in everyday life. It is as if we are peering directly into the moment the universe began. Yet, such immense power brings with it an immense responsibility. Consider the incident involving Russian physicist. 5 minutes and 36 seconds. Anatoly Bugorsky. In 1978, Bugorsky was conducting research at the U.S. synchrotron at the Institute for High Energy Physics when a tragic accident occurred. A proton beam accidentally penetrated his skull, causing significant tissue damage. Miraculously, he remained conscious and even walked to seek medical attention. His experience serves as a stark reminder of the potential dangers associated with particle accelerators. The power harnessed by these machines should never be underestimated. Concerns about the 6 minutes and 8 seconds. LHC's capacity to create black holes, albeit on a very small scale, have raised alarms among some in the academic community. Black holes are regions of space with such intense gravity that not even light can escape. Some scientists have expressed concern that the LHC might create a miniature black hole, one that could theoretically consume the Earth from the inside. While CERN researchers have reassured the public that any black holes generated would evaporate almost instantly and pose no threat to the 6 minutes and 37 seconds planet, this theoretical possibility has nonetheless sparked fear and intrigue. And so on. Despite assurances from CERN scientists, the fear surrounding the potential risks of high-energy collisions remains. Could the formation of a black hole, even a microscopic one, trigger a chain reaction beyond human control? Could the very fabric of space-time be disrupted in ways we have yet to comprehend? These concerns are not without precedent. Theoretical physics is filled with paradoxes, uncertainties, and phenomena that challenge our fundamental understanding of reality. While most experts agree that the LHC poses no existential threat, some argue that we are venturing into uncharted territory where even the most advanced models may fail to predict every outcome. 7 minutes and 21 seconds. Among those expressing caution is Dr. Eric Volmont, a respected theoretical physicist who has studied quantum gravity for over 2 decades. In a recent interview, he posed a chilling question. What if our equations are incomplete? What if the conditions we are recreating at CERN act as a key, unlocking a phenomenon we never intended to access? Volmont suggests that, beyond concerns of black holes, the extreme energy levels within the LHC could potentially disrupt an underlying layer of reality, a hidden structure within the quantum vacuum. The concept of vacuum decay, as proposed by Stephen Hawking and others, suggests that the universe exists in a delicate energy state. If disturbed, this state could transition into a lower energy form, resulting in a cascading effect that could unravel the very essence of matter itself. 7 minutes and 56 seconds. While this theory remains highly speculative, it highlights the fundamental question of scientific responsibility. How far should we push the boundaries of knowledge when the risks, however small, carry consequences that could extend beyond our planet, beyond our understanding of existence itself? Some researchers have gone further, speculating on the possibility that the LHC might open doorways to new dimensions. String theory, one of the most ambitious attempts to unify physics, suggests the existence of hidden dimensions beyond the familiar 3 of space and 1 of time. These dimensions, if real, remain imperceptible under normal conditions. However, at extreme energy levels, they could, in theory, become accessible. 8 minutes and 29 seconds. Dr. Elena Vasquez, a CERN scientist specializing in high-energy physics, recently addressed these concerns. The LHC is not designed to create interdimensional rifts or summon unknown entities from the void, as some conspiracy theorists claim. However, if extra dimensions exist, our experiments could provide indirect evidence of their presence, perhaps through the behavior of gravity at microscopic scales. Her words were meant to reassure, but for some, they only deepened the mystery. If the LHC could indeed interact with hidden layers of reality, what might we discover? And what might discover us in return? 8 minutes and 59 seconds. The idea of unintended consequences looms over every major scientific endeavor. When the first atomic bomb was tested in 1945, some scientists feared it might ignite the Earth's atmosphere. That fear proved unfounded, yet the weapon itself reshaped the course of history. Could the LHC be our generation's equivalent, a technological marvel with repercussions beyond our ability to predict? With the LHC undergoing new upgrades, preparing for even higher energy collisions, these questions remain more relevant than ever. As humanity delves deeper into the unknown, we must ask ourselves, are we explorers of the cosmos, unlocking the secrets of existence? Or are we children playing with forces we scarcely understand, standing on the precipice of something far greater and far more dangerous than we ever imagined? As the LHC prepares for its next series of high-energy collisions, an unsettling event takes place, one that defies explanation. It begins with a routine test. Scientists in the control room monitor the accelerator as it brings proton beams to near-light speeds. Everything appears normal until, for a brief moment, an anomaly registers on the instruments. A fluctuation in energy, so minuscule that most would dismiss it as a data glitch. But then, a second fluctuation follows. And a third. Dr. Vasquez, standing over the main console, frowns. "That's impossible," she mutters. The readings indicate a brief but measurable distortion in spacetime, something that, according to current models, should not occur at this scale. 10 minutes and 5 seconds. The disturbance lasts only 4.8 milliseconds, but in that time, sensors across the LHC's underground tunnels detect something else, an unaccounted-for burst of radiation unlike any previously recorded. Not standard electromagnetic waves, nor high-energy neutrinos. Something different. Dr. Eric Volmont, reviewing the data from his private research lab in Geneva, receives a notification about the anomaly. When he sees the waveform signature, a chill runs through him. He's seen this pattern before. Years ago, while conducting an independent study on quantum fluctuations, Volmont theorized that if an experiment ever reached a critical threshold, where energy densities became high enough, it might not just reveal unknown particles. It might allow a glimpse into something deeper, a fundamental layer of reality hidden beneath the observable universe. He never imagined he'd see evidence of it in his lifetime. 10 minutes and 42 seconds. A conference call is quickly assembled. CERN's top scientists, engineers, and theorists gather in the secure briefing room, their faces illuminated by the eerie glow of data projections. Vasquez stands at the podium. "We need to address what just happened. The energy distortion at collision point alpha 7 was," she hesitates, "anomalous. It suggests a local curvature in spacetime. Something bent." The room is silent. No one dares to speak. Then a voice from the back, Dr. Marcus Leclerc, an expert in black hole thermodynamics. "Bent? Are you saying we created a singularity?" Vasquez shakes her head. "Not a black hole. But something interacted with the proton beams in a way that shouldn't be possible under current physics. The distortion wasn't random. It had structure. A pattern." She switches the display to a high-resolution scan of the anomaly's energy signature. The waveform appears on screen, a pulsating, shifting frequency that seems almost intentional. That's when Volmont speaks. His voice is low, cautious. "That pattern isn't random. It's repeating. Almost as if." He pauses, the weight of the realization settling on him. "As if something responded to us." 11 minutes and 19 seconds. The words hang in the air like an unspoken truth no one wants to acknowledge. For decades, scientists have theorized about extra dimensions, parallel realities, and hidden structures within the quantum vacuum. But no one expected a sign that something, or someone, might already be there. Watching. Waiting. The room erupts into debate. Some argue it's just noise, an artifact of the high-energy environment. Others insist on further investigation. But Vasquez and Volmont know better. The readings are too precise, too deliberate. Whatever happened inside the LHC was not an accident. It was contact. 11 minutes and 52 seconds. But with what? The decision is made. The next test will go forward, but with extreme caution. The world outside remains oblivious to the events unfolding beneath Geneva's surface. To them, the LHC is simply a scientific marvel, a monument to human curiosity. But to those within CERN, a chilling question lingers. Have we just knocked on the door of something that was never meant to be opened? And worse, has something started knocking back?